Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have n to the power of 5 minus 1 is equals to 0, and we will solve this problem for the values of n. So the very first thing we are going to do is, here first I can find the root of this equation, and clearly you can see that if I can substitute here n is equals to 1, then it satisfies the given question. So it is 1 to the power of 5 minus 1 is equals to 0, and here we see that 1 minus 1 is equals to 0 and 0 is equals to 0. So we say that n minus 1 be the root of given equation. Okay, so n minus 1 be the root of this given equation, and now I can use here the division algorithm or division method to find the factors of this equation, so that I can divide here this equation n to the power of 5 minus 1 by n minus 1. So now we will divide this term by n minus 1, and here you see that first I can multiply its term by n to the power of 4. So when you multiply n to the power of 4, you will get n to the power of 5 minus n, and now you can subtract these terms and you see that these are gone, and here you get n, this is n to the power of 4, n to the power of 4 minus 1. And now in the next step we can again multiply this term by n to the power of 3, because here we need to make n to the power of 4, so that we multiply this equation by n to the power of 3. So when you multiply n to the power of 3, you will get n to the power of 4 minus n to the power of 3, and now you can again subtract these terms and you see that these are gone, and here you get n cubed minus 1. So now you make n cubed here, so you can multiply this equation by n square. So when you multiply this equation by n square, you will get n cubed minus n square, and I can write it here, n cubed minus n squared. So now you can subtract these terms, and these two terms are gone, and here you obtain n squared minus 1. So here we need to make n square, so that we multiply this term by n. So when you multiply it by n, you will get n squared minus n, and here you get n squared minus n, and now we again subtract these terms and you can see that these are gone, and here we get n minus 1, and now we multiply this equation by plus 1, so that we will obtain n minus 1, and finally you obtain n is equals to 0. So after taking all division, we obtain here n to the power of 5 minus 1 is equals to n minus 1 times of n to the power of 4 plus n cubed plus n squared plus n plus 1. And because in the start of the question we have n to the power 5 minus 1 is equals to 0, so that we can write here this term is equals to 0. So here we have two cases. The first case is we take n minus 1 is equals to 0, and the other case is we take, first is n minus 1 is equals to 0, and the second case is we take n to the power of 4 plus n cubed plus n squared plus n plus 1 is equals to 0. So in this case you get the value of n is equals to 1. So this is the first root of the given equation, which we already find this root, and now we move towards this factor, and in this factor first I can divide this each term by n square, because it is the reciprocal equation, and the reciprocal equation is the equation in which when you can replace n by 1 over n, you will again get this equation. So that this is the reciprocal equation, and the method to solve the reciprocal equation is that we can divide each term by n squared. So when you divide each term by n squared, then you obtained the output in the form of, here you see that this square are gone, and here you obtain n squared plus this n square and n cube are gone, and here you get n, and these are gone, here you get plus 1, and here these are gone and you get 1 over n, and similarly here you get 1 over n squared is equals to 0. Now we rearrange the terms and we can make the pairs of square terms and all other terms. So that first I can make the pair of n square plus 1 over n square. After that we make the pair of n plus 1 over n, and here you have plus 1 is equals to 0. And now we again make some little bit simplifications here, so that now I can just take y is equals to n plus 1 over n. So when you can put y is equals to n plus 1 over n, and you obtain y squared is equals to, now I can make the squaring on both of the sides of this equation in order to find the value of n square plus 1 over n square. So that here you obtain n square plus 1 over n square plus 2, because 2 times of n into 1 over n, and the next terms are cancelled about each other and you get only 2. So now we move this 2 in the left hand side, and you get y square minus 2 is equals to n squared plus 1 over n square. And now we put n plus 1 over n is equals to y in this equation, and n square plus 1 over n square by y square minus 2. So this equation will becomes, here you have n square plus 1 over n square, it is equals to y squared minus 2, and plus n plus 1 over n is equals to y, and plus 1 is equals to 0. So here you obtained y square plus y minus 1 is equals to 0. And now we make the factors of this equation, or you can apply the nice quadratic formula here. So now I can apply here the nice quadratic formula, and here you have a is equals to 1, b is equals to 1, and c is equals to minus 1, and our quadratic formula is y is equals to minus b plus minus b squared minus 4 times of ac square root over 2 times of a. And now we can put all the values of a, b and c in this formula, and you obtain minus 1 plus minus 1 minus 4 times of a and c. Here you have the value of c is minus 1, so this minus and minus will becomes plus 4, and its square root over 2. And here you can little bit simplify the terms, and you get minus 1 plus minus square root 5 over 2. So here you have two cases. The first case is you take y is equals to minus 1 plus square root 5 over 2, and the other case is you take y is equals to minus 1 minus square root 5 over 2. And now I can first solve the case number 1, so this case, and in this case you have y is equal to this one, and the value of y I can put in the start of the question is n plus 1 over n. So n plus 1 over n is equals to minus 1 plus square root 5 over 2. Now I can first simplify this case, so that here you can take the LCM, or you just multiply both sides by 2n. So now I can multiply both of the sides by 2n. So here you see that this 2n is multiplied by this equation, and you obtain 2n square, plus when this 2n multiplied here you get plus 2 is equal to this 2 and 2 are gone, and you get n times of square root 5 minus 1. And now we move this equation in the left hand side, and you get 2n squared minus square root of 5 minus 1 into n plus 2 is equals to 0. Here we again apply the nice quadratic formula, and you can get the roots of this equation. So that here you apply the quadratic formula, which I can write above in this question, and now I can apply directly this formula here. So you obtain minus b, and you get minus 5 square root plus minus square root of 5 minus 1 whole squared minus 4 times of a is 2 and c is 2, and its square root over 2 times of 2. And now we can simplify the terms, and here you can just open this formula and you can just add or subtract all the terms, and you finally get the value of this question is square root of 5 minus 1 plus minus, after simplification of these terms you get 10 plus 2 times of square root of 5 into iota and its whole square root, and whole over you have 2 times of 2 is equals to 4. So these are the two roots of the given equation, and this I can solve the first case. And similarly, when you solve this case, you can similarly obtain the value of the roots are minus 1 minus square root of 5 into plus minus 10 minus 2 into square root 5 and its whole square root iota over 4. So these are the again two roots of the given equation. So finally we say that the 5 roots of the given equation are the 2 roots are this one, 2 roots are this one, and its one root is n is equals to 1. So these are the 5 roots of the given equation, and this is our final answer. Thank you so much for watching this video. Please subscribe to my channel for more exciting videos.